Hello, dear students. I welcome all the Standard 7 students on this online classes. So, previous class already we have discussed and learned about simple pendulum and the factors affecting the time period of a simple pendulum and the different terms related to simple pendulums. And I hope all of you have understood that one. Okay. So today we will be going to discuss about scalar and vector quantities and random motions, then distance and displacement. About distance and displacement already we have discussed. Today again we will be going to discuss that one and learn that one so that you can understand that one properly. Okay. So without delaying, let's get started this one. So scalar quantities and vector quantities. All the physical quantities are divided into two types, that is scalar and vector quantities. Okay. So a physical quantity which has magnitude only but not any specified directions is called a scalar quantity. So what is the meaning of scalar quantity? If the physical quantity is having only magnitude or the size, and from that unit or from the physical quantity, if we understand only the magnitude without having any direction, then it is called as scalar quantities, like length, distance, speed, area, volume, time, mass and energy are all scalar quantities, because whatever the physical quantity is, it is given, that is having only magnitude. Length is not having any directions. Yes, distance is also not depend upon the directions. Time is also not having any direction. Only it is having magnitude. Exactly like that, the opposite of scalar quantities, another one is the vector quantity, which is having both magnitude as well as directions. Examples: force. Yes, force is a vector quantity because it is having magnitude as well as directions also. On which directions we are applying force, that one we must have to mention. Then weight, always acting vertically downward directions, which is also having direction as well as magnitude. Displacement is also depend upon that direction. Then velocity, accelerations, all are vector quantities. Okay. So scalar and vector quantities, I hope all of you have understood. Then the next one, random motion. So different types of motions already we have discussed. Yes. So here one more type of motion it is given, that is random motion. So have you ever observed the motions of flying bees and butterflies? Yes. So do they move about in a haphazard manner in all possible directions? When a body moves in a haphazard manner in all possible directions, its motion is said to be random motion. Yes, they are not moving along a straight line or around a fixed path. Yes, or along a fixed line. They are not moving like that. They are moving haphazardly. Yes. So flying houseflies, bees, butterflies, and players and ball in a hockey or football game are common example of random motion. No particular or definite type of motion is called as random motion, or haphazard motion is called as random motions. Okay, simple one only. Then the next one, about distance and displacement. This one also already we have discussed. So let us try to understand more clearly about this one. Okay. So here you can see that one first figure 2.17, it is given. So what is the meaning of distance? Just I am going to explain about that one. The length of the actual path traveled by a moving body in a certain interval of time. In a particular certain interval of time, how much amount of path or the length of the actual path covered by a moving object, that one is called distance. And distance is irrespective of the directions of travel. Okay, that one is called distance. So here the example is given, a body, let us consider a body starts from A. Okay, so from A to B it cover 3 meter, then B to C it cover 2 meter, then C to D it cover 5 meter. Okay, so if we want to calculate the how much distance traveled by that moving object. Then how can we calculate that one? Then total length of the path covered by the body is equal to AB plus BC plus CD. So 3 plus 2 plus 5 is equal to 10 meter. So the total distance traveled by a moving body can also be defined as the length of the path between the initial positions and the final positions of the moving body in a given interval of time. In a given interval of time, which path we are following. Okay, and if we will measure the followed path, the length of the followed path, that one becomes the distance only, which is irrespective of the directions. Okay, I hope you have understood that one. Then displacement. So here you can see that one. At point A, home is present, and at point C, school is present. So different path we can follow. So from A to C, we can follow DE path or F or B, like that we can go. Yes or no? So there may be different routes or routes from A to C through B or F or D and E, by which we can reach the school. That is, by different routes you can cover different distances. So while we are following different routes, at that time we must have to cover different types of distances also. Yes? But imagine if you could move directly to your school without any turn or without any other type of motions or path, then what will happen? Then you shall be covering the shortest distance, as it is obvious from the sketch shown in the figure 2.18. So from point A to C or from home to school, if we will try to move in a straight line or on a straight line, then the dotted line indicating the shortest distance between home and the school. So that one is the displacement. So it is the distance or the shortest distance between 2 points. One is initial, another one is final one. That one becomes the displacement. Okay? But the rest of all are the other quantities. Like we can say that one, the distance also. Okay? So let us see that one. So distance and displacement, the length of the actual path traveled by a moving body in a certain interval of time, irrespective of the directions of travel, is called distance. So for example, a body moves, that example is given, this one, explanation about that example. So from A to B it covered 3 meter, B to C it covered 2 meter, and C to D covering 5 meter. Okay, then total length of path covered by the body is equal to, by adding each part, okay, then we will get the total length or the distance we will get, that is 10 meter only. Okay, but the displacement, the shortest distance between initial and final positions of a moving body is called the displacement of the body. This one is the definitions of displacement. So for example, if you analyze the path from your home to school, there may be different routes or different path which we need to follow. Yes? So here, so from A to C, through B also we can go, through F also we can go, through D also we can go, and through E also we can go, by which we can reach the school. So that is, by different routes you can cover different distances. If we are following different routes, then we must have to cover different distances also. Yes? But if we imagine, okay, let us imagine if you are following directly to your school without any turn or without following any other path, directly. So directly means the straight line joining the home and school, that one should be the direct path only. Yes, then you shall be covering the shortest distance, as it is obvious from the sketch shown in figure 2.18. So in the sketch, AC is the shortest distance, that is the displacement. Okay, is AC. So I hope all of you have understood about distance and displacement. Again, you must go through your book also. And the unit of distance and displacement are same. The SI unit of both distance and displacement is meter only, and the CGS system, the unit of distance and displacement is centimeter only. But one is scalar quantity, another one is vector quantity. So which one is scalar and which one is vector? Obviously distance is a scalar quantity which is having only magnitude, which is irrespective of direction, but the displacement is having both the direction as well as magnitude. So it is a vector quantity. Okay. So I hope all of you have understood this one. Thank you.